Hello students, how are you all? Welcome back to Akshar ID Foundation classes. I am your chemistry faculty S. Mohan. So students, grade 8 under the ID Foundation volume 2 we are discussing mole concept and stoichometry, right? And today we are going to discuss about the last and final synopsis of this chapter, that is fifth synopsis. Okay, so students, here in the previous class we've discussed about the oxidation and the reduction in the fourth synopsis, right? What is with oxidation? I give some definitions to you. What are the oxidations? Addition of oxygen to a given compound or element, or removal of oxygen from a given compound is called the oxidation. This is normal definitions. Apart from that, removal of electrons from any atom is called oxidation. Removal of electrons, okay, is called oxidation. So here, for example also I said you that, for example, here sodium, okay. So sodium, by losing one electron, if it loses one electron, it becomes Na plus, okay. So sodium is losing one electron to become sodium ion, right? So this is called oxidation because it's losing the electron. Similarly, what is reduction? Gaining of electrons. Suppose other two examples or other two definitions of the one is addition of hydrogen or removal of oxygen is called reduction. Apart from that, what I said, gaining of electrons means taking of electron is called a reduction. Example, chlorine is there. So chlorine, if it takes one electron, it becomes Cl minus, chloride ion. So this is a reduction. What it is? A reduction. And this is a oxidation. This we discussed in the last class. Oxidation and reduction. And one more easily to remember, how can we say that it is oxidation or reduction? So here, if you see, this is a neutral atom, right? For neutral atom, oxidation number is 0. What oxidation number? 0. Here Na plus. Plus means what? Plus 1. So here it is plus 1, right? So 1. So here oxidation number increased from 0 to 1. Increased from 0 to 1. So this is called oxidation. If the increase in the oxidation number takes place, then that is called oxidation. Now here you see chlorine. Chlorine, what is the individual atom? So here oxidation number is 0. But here if you see minus, means what? Minus 1. So here from 0 to minus 1. Minus 1 is less than 0. Yes or no? So here the oxidation number is decreased here. So this is called a reduction. So oxidation number decrease. Decrease in oxidation number is reduction, and increase in oxidation number is called oxidation, right? So removal of electron is called oxidation. Addition of electrons or gaining of electrons is called reduction. Based on this, we discussed in the last class so many examples along with some exercise questions also, right? Chalo. So today we started the synopsis 5. Today we start the synopsis 5, and the synopsis 5 is redox reaction. Okay, what it is? Redox reaction. Chalo students, what is meant by the redox reaction? Once you see the name redox, good. So redox means what? In the redox you can see red for reduction, ox for oxidation. A reaction in which both oxidation and reductions takes place simultaneously. Okay, so how can you define a reaction? A reaction in which both oxidation and reduction takes place, okay, simultaneously, okay, is called redox reaction. Means what? In one reaction only, both the reactions are taking place like oxidation and reduction. Both the reactions are taking place in one reaction only. That is called redox reaction. Okay. So for example, example, what we can take, okay, let us see copper oxide, CuO. Okay, copper oxide formula is what? CuO. Now this red hot, it's a hot, okay, copper oxide, and above this copper oxide, if we pass the hydrogen gas, if we pass the hydrogen gas over the hot copper oxide, then what happens? Here this hydrogen takes out the oxygen to form water and the copper. Okay, we can get. So on passing the hydrogen gas over the copper oxide, it gives copper and water. Right? Now, how can you say this is a redox reaction? So redox reaction means what I said, if both oxidation and reduction, both the reactions takes place simultaneously in one reaction only. So in this reaction only, if two reactions takes place, then that's called now how can we say? See here, this is copper oxide, and you know that oxygen oxidation number is -2, right? And copper oxidation number is +2. This already we discussed. Now this hydrogen is individual, so this is 0. Now copper, here it is individual, so this is 0. And here hydrogen is +1. You know that hydrogen oxidation number is +1 and oxygen is -2. Done. Okay. Now see students here. Here if you see here copper oxidation number is what? +2. Here copper oxidation is what? -2. So here what's happening here? +2 to 0. Sorry, here 0. Copper is 0. So +2, here copper is 0. So +2 to 0. The meaning is what? The oxidation number is decreased. +2 to 0. So that is decreased. So decreasing is called what? Reduction. So from here to here, which reaction took place here? Reduction reaction took place here, right? Now see here now. Okay. Now see here now. Oxygen. Oxygen is what? -2. Here, not oxygen, let's take hydrogen we take. Okay, see here, hydrogen oxidation number is what? 0. But here oxidation number is what? +1. Okay, so here what happened here? 0 to +1 means what? Increased. So 0 to +1. So increase in oxidation number is called what? Oxidation. So this is what? Oxidation. Okay, in single reaction, both oxidation and reductions are taking place. So such reactions are called redox reaction. So here for one element oxidation number is decreasing, for one element oxidation number is increasing. Increase in oxidation number is called oxidation, decreasing in oxidation number is called reduction. So both are taking place in single reaction. Such type of reactions are called redox reactions. Clear? Chalo, 1 minute I'll give. Just see this one. Okay. Chalo, see now. Chalo, right student, finished? Okay. So I hope you understood clearly about the redox reaction. So here today our topic is types of redox reactions. Okay. Types of redox reactions. Okay. So types of redox reactions. What is the type of redox reactions? So redox reactions, different types. Okay, how many types of reactions are there? Now we discuss one by one. In that first one is a chemical combination reaction. So first one, see students here, chemical combination reactions. I think somewhere it has come in your normal NCERT syllabus. Okay, combination reaction. This is very simple. Okay, so a chemical reaction in which two or more reactants combine to form a single product. Okay, combination, normally in the English, what is the meaning of combination? Combining, right? So here the reactions in which two or more reactants will combine to form a single product. Okay, so that is called combination. Okay, so example, so many examples we can give, like carbon burns in oxygen to form a carbon dioxide. Yes or no? So this one example we can give simply. Okay, so carbon burns in oxygen. Okay, O2. So it gives rise to carbon dioxide gas. So this is a combination reaction. So carbon and oxygen both are combining to form a single product. Clear? So like this, so many examples. Magnesium burns in oxygen together. Magnesium oxide hydrogen react with chlorine to form a hydrochloric acid. Hydrogen react with oxygen to form a water. And calcium oxide react with water to form the calcium hydroxide. Like this, so many reactions we can give where two or more reactants. These are called reactants. Already you know which are taking part in the chemical reaction are called reactants. So two or more reactants are combining to form a single product. Product is one, but reactants may be two or more. Such type of reactions are called chemical combination reactions. Okay, so this is a chemical combination reaction. Did you understand? So two or more reactants combined to form a single product is called a chemical combination. That's all. Combination. Very easy. Okay, I hope you understood. Now the question is that, so we are discussing about the redox reaction and explaining about the chemical combination, how this reaction is a redox reaction. That's the question, no? Chalo, that also we'll discuss. So here you see now, here, okay, so here this is a individual carbon. Carbon is individual. So what is its oxidation number? 0. Yes or no? Right. Now here oxygen, individual. So oxidation number is 0. Here oxidation number of copper is 0. Carbon is 0. Here the oxidation number of oxygen is 0. Correct? Chalo, now come here this side now. Here this is a compound. You know that oxidation number is -2. So minus like this, how many oxygens are there? 2 oxygens are there. -2, 2s up, -4 means what? Carbon is +4. So the oxidation number of carbon here is +4 and oxygen is -2 in the right side, but in the left side carbon oxidation number is 0, oxygen number is 0 because they are individual. Alright, now you check now. Here carbon is 0. Okay, now here you can see carbon is +4. So 0 to +4. Is this increase or not? Increase. So this is increase in oxidation number. So this is called what? Oxidation. What it is called? Oxidation. Now let us see. Here oxygen. Oxygen is what here? 0. Here you see the oxygen -2. 0 to -2. So -2 is less than 0. You know that. So here this is what? Reduction. Decreased in oxidation number is called reduction. So in that when carbon combines or burns in oxygen to form a carbon dioxide, here two reactants and product is 1. So this is called a combination reaction. This is combination reaction. And it is a redox reaction because here carbon oxidation number is 0 to +4, it is increasing, and oxygen 0 to -2, it is decreasing. So hence it is okay, redox reaction. Clear? So once go through this equation for 1 minute. So this is a chemical combination along with the redox reaction. Okay, chemical combination along with the redox reaction, right? So here this is a chemical combination. Two or more elements or compounds or reactants are combining to form a single product. It's a chemical combination, but it's also a redox reaction. But friends, here all chemical combination reactions are not redox reactions. Okay, so when you say the redox reactions, if there is a change in the oxidation number, then we can see the redox reaction. Okay, but here if you see some other examples, if you see here, okay, for example, you see calcium hydroxide, sorry, calcium oxide, that is CaO. When it reacts with water, H2O, it forms calcium hydroxide, CaOH taken twice. So this is the calcium hydroxide formation. Now if you see here, calcium oxidation number is +2, oxygen is -2, hydrogen is +1, oxygen is -2, right? Yeah, calcium again it is +2, oxygen is -2, hydrogen is +1. So here if you see here, calcium +2, here also calcium +2, no change in the oxidation number. Now here oxygen -2, here oxygen is -2, here also no change in the oxidation number. and here hydrogen is +1, here also hydrogen is +1, no change in the oxidation number. So in some reactions, see, all these are the combination reactions. All combination reactions are not redox reactions. Remember this point. This is very important point. Okay. So where only there is a change in the oxidation numbers, or where there is an involvement of the loss or gain of electrons, such reactions are only considered as the redox reactions. Clear? So chalo. So this is a combination. This is redox reaction. So, but if they ask anyone that whether all combination reactions are redox reaction, means what? No. That's your answer, right? Chalo, I hope this you understood. Now then come to the second type of reaction. What the second type of reaction is? Decomposition reaction, students. What is the second type of reaction? Decomposition. Decomposition reaction. So what is the decomposition? This is exactly opposite to the combination. In the combination, what we study, two or more reactants will combine to form a single product. Okay, reactants two or more, but product is one. But here ulta exactly. Reactant is one, products are many. Reactants are one, products are many. Okay, two or more products. So ulta exactly opposite to this one. So example here in your material, what is given here? Okay, mercuric oxide. Okay, so mercuric oxide, if you see here, HgO2, HgO, on heating, it splits into Hg plus O2. Okay, so here you see here 2HgO on heating, it's splitting into mercury and oxygen, right? So here you see, students, here this is one compound. Right, HgO is one compound. On heating is splitting into two elements called mercury and oxygen. Okay, so one reactant is giving two products, one and two products. Correct. Now, so this is called a decomposition, a reaction in which a single reactant decomposes, means what, breaks or splits. Okay, into two or more products is called a decomposition reaction. So here also, here reactant is one, but products are two. So this is splitting into two products, right? So this is a decomposition reaction. First, try to understand the decomposition reaction definition. Okay. So definition according to material is also what a decomposition reaction is, a type of chemical reaction which one reactant yields two or more products. One reactant decomposes splits into two or more products. That is called a decomposition. Okay. Now this is done. Now, how come it redox reaction? Okay, now let us see, check now whether it's a redox reaction or not. So here you know, students, here oxygen is -2, you know that, and oxidation number of mercury should be +2, because if both are neutralized, means 0, that should be -10 +2. And here mercury is individual, it is not associated with any atom, so the 0. Oxygen also individual, it is not associated with any atom, so 0. Okay, now if you check now, mercury here is here -2, sorry, +2, mercury is +2, +2 to 0, +2 to 0, +2 to 0 means what? It is decreased by 2 units, yes or no? So oxidation number of mercury is decreased by 2 units, +2 to 0. So this is called reduction. What it is called? Reduction, right? Now if you see the oxygen, here oxygen is -2, here oxygen is 0. -2 to 0, the meaning is what? It is increased. -2 to 0 means what? It is increased. So there is an increase in the oxidation number. So this is oxidation. Okay, so both are taking place together. So hence it is a redox reaction. So the reaction in which both oxidation and reduction reactions takes place simultaneously is called as a redox reaction. So this is redox reaction, right? So this is decomposition reaction. This is redox reaction. Okay. So decomposition means what? In which one reactant decomposes, splits into two or more products, right? And this is a decomposition reaction, and here oxidation and reduction both are taking place. Hence it is redox reaction. So this is the decomposition redox reactions. Okay. Now, same point, you have to remember that all decomposition reactions are not redox reactions. All decomposition reactions are not decomposition reactions. Okay. For example, you can take here one example is given in your material. Once if you see the magnesium carbonate. Magnesium carbonate on heating, it gives magnesium oxide and carbon dioxide. So here you know that magnesium belongs to a second group, so +2, oxygen -2, -2, 3 is a -6, -6 plus 2 is -4, so the carbon is +4 here, right? Here magnesium is +2, oxygen is -2, oxygen is -2, -2, 2 is a -4, means it should be +4. Now here if you see magnesium +2, no change, carbon +4, no change, oxygen -2, no change. Okay, so there is no change in the number of electrons. Okay, or addition or gaining, means removal or gaining of electrons. So here again oxidation number in the reactant side also, product side also same. So such reactions are not considered as a redox reaction. Clear? So here it can be considered as a redox. Why? Because here +2 to 0, -2 to 0. Okay. So here reducing, here oxidizing. Clear? So hence this is about the redox reaction about decomposition. Clear? One see this one. Chalo. Let's go to third type of reaction. What the third type of reaction is given your material? Disproportionation reaction. What's the third one? So students, here disproportionation reaction. What is meant by the disproportionation reaction? In the disproportionation reaction, one element from the reactant side, observe, listen carefully, one element from the reactant side undergo both oxidation and reduction. Very simple. Okay. Here if you see in the previous one, mercury is going reduction, oxygen is going oxidation. Two different elements are going. One element is going reduction, one element is undergoing oxidation. Here you see carbon is undergoing oxidation, oxygen is undergoing reduction. Okay. So here also one element is under oxidation, the other one is going under reduction. Right? So two different elements are going into oxidation and reduction. Right? But here what happens? One element only undergo both the oxidation and reduction. Both the oxidation and reduction. Example is given, mercury chloride decomposes into mercury and mercury chloride. So see here now, example, mercury chloride, Mg2Cl2. What is the formula? Mg2Cl2, this is a mercury chloride. Okay. On heating, it decomposes, means what splits, like how mercury, that is Hg. So out of two Hgs, one Hg has come here, more one Hg is left. That one Hg reacting with the chlorine to form the mercury chloride. Okay. So this is a reaction. Okay. So here Hg2Cl2, Hg is mercury. So mercury chloride, Hg2Cl2, it decomposing into mercury and mercury chloride. Clear? Now see here students, now here let us see the oxidation numbers. Here you know that chlorine oxidation number is -1. So -1 to the -2 means this should be +2. So 2 mercuries are there, each mercury is a +1. This is the oxidation number of mercury. Here. Now here if you see, it is individual mercury. So the oxidation number is 0. Here you know that chlorine is -1, but here it is 2 chlorines. So to balance it, to make it 0, so this should be +2. Okay. So these are the oxidation numbers. Now observe carefully here. Here mercury. So mercury plus 1 to 0. Plus 1 to 0 means what? Decreasing. Decreasing is what? Reduction. Decreasing is what? Reduction. Which element is going under reduction? Mercury. Mercury is undergoing reduction. Clear? Chalo. Now once again you see a mercury. So mercury here plus 1. Here you see plus 2. Here plus 1. Here is showing the oxidation number plus 2. Here plus 1. Here plus 2 means what? 1 to 2 increased. So here oxidation number is increasing. So this is called what? Oxidation. What it is called? Oxidation. Alright. So here which element is undergoing oxidation? Mercury is undergoing oxidation. Which element is undergoing reduction? Mercury is undergoing the reduction. So the meaning is what? One element only from the reactants. One element only from the reactants is undergoing both oxidation and reduction to form the two different compounds in the products. Clear? Such type of reactions are called disproportionation reaction. Clear to you? So mercury only undergoing reduction, mercury only undergoing oxidation. So mercury, where is it? It is in the reactant side. Mercury is what? It's a reactant. So the reactant mercury, a single element, is undergoing both oxidation and reduction. So this is called disproportionation reaction. Once if you have a material, open the page number 83. Okay. So the definition you can see, disproportion reaction, sometimes also called a dismutation, is a redox reaction in which one compound of intermediate oxidation state converts into two compounds, and one of higher and one of lower oxidation states. So one element only undergoing both oxidation and reduction from the reactant side to form the two products. Okay. So this is called a disproportionation reaction. Okay. Chalo, once see this one. Okay. So that's about the disproportionation reaction. Now what is the next reaction? Next reaction is a comproportionation reaction. Oh, very easy, exactly opposite. Here combination is opposite to decomposition. Disproportion is here opposite to comproportionation. So the disproportion is what? One element from the reactant side is undergoing both oxidation and reduction. Correct? But comproportion is exactly opposite. So here two elements means here two reactants. The two reactants will be there. In the two reactants, one common element will be there. This common element undergoing both oxidation and reduction. You didn't understand now? Okay. Let's see now. Comproportionation reaction. Exactly opposite to the disproportionation reaction, students. Okay. So here for comproportionation reaction example, what you can take here. Okay. So see here, lead, that is what Pb. What example is given in your textbook, that one I am explaining. Pb plus lead oxide plus sulfuric acid H2SO4 and giving lead sulfate PbSO4 plus 2H2. Okay. Is it balanced? Let's check. 1 plus 1, 2 Pb, 2 Pb, okay. 2 oxygens, 2 4s are 8, total 10. 2 oxygens, 2 4s are 8, 10. It should be there 10. Yeah, so you can write here to correct only. Okay, then it's balanced. Okay, so here you see, if you observe in the reactant side, students, see here, observe carefully here. Lead oxide and sulfuric acid are combining to form the lead sulfate and water. Pb is lead, you know. Okay, so in the reactant side, these are called reactants, right? These are called reactants. In the reactants, one element is present in two times. Can you see here? Here. Okay, one element only is present in two places. So two times, right? But right side, if you see, that element is only in the reactant product side, only one time is there. Only one time, right? Now, let's write the oxidation numbers of this reaction. Come on, you try now. Oxidation numbers. You know how to write the oxidation numbers. Come on, try fast. Otherwise, you say loudly, you say, what is the oxidation number of lead? Its individual atom. +2, 0. If it is individual, that is what? 0. Correct? That is what? 0. Now here you say, what's the oxidation number? Oxygen is -2. -2, 2 is a -4. To make A 0, it should be +4. So lead oxidation number is +4. Right? Now here oxygen is -2, hydrogen is +1, sulfur is +6. Already we have done so many times. Okay. Once again, if you see, oxygen is -2, sulfur is +6, and lead is +2. Okay. Next here, oxygen is -2, hydrogen is +1. Over. These are the oxidation number we got here. Correct. Now see what's happening here. I will do one thing. Now I'll do one thing. See here. First I will write this part. Only this part, because here lead is there, here also lead is there. First I will write this part once for your understanding. So Pb of some part only I am writing. Okay. Only some part I am writing. Pb here left side. Right side is what? PbSO4. Okay. And it is 0. Here it is +2. Okay. 0 +2. So here it is what? 0 to +2 increase. So this is called what? Oxidation. Alright. Now here also Pb is there. See a PbO2. Now this only I'll take, because Pb here. Now what happens here? See, PbO2 gives rise to PbSO4. Here what is its oxidation number? +4. Here what is the oxidation number? +2. Okay. So +4 to +2 decreased here. Okay. So this is what? Reduction. Okay. So which element here it is undergoing the oxidation? Lead. Which element is undergoing the reduction? Lead. But whether these two are the same element or same compound? No. So here this lead is different. This lead is different. Two different compounds. Two different reactants. But lead sulfate PbSO4 here same. PbSO4 here same. Right. So the product lead sulfate is same. Reactants, two leads, different leads are there. But the products only one lead is there. So here this is called proportionation. The disproportionation, what I said, reactant side 1 mercury, but product side 2 mercuries. Reactant is 1, products are 2. But here reactants are 2, but product is 1. Okay. So there one reactant is undergoing the oxidation and reduction in the two different products. But here two different reactants are undergoing the oxidation and reduction in for single product, to form a single product. So exactly opposite to this one is proportionation reaction. Once you see the definition, proportionation reaction or proportionation is a chemical reaction where two reactants each containing the same element. Two reactants each containing the same element. Lead here also lead. Okay. But with a different oxidation numbers. See a 0 +4, 0 +4. With the two different oxidation numbers form a product. So these both are forming a product. This is a product in which element involves reach to same oxidation number. Now here only one lead, here lead is there. Here both are having the same oxidation number. Clear? So such type of reactions are called proportionation reactions. Clear? So once go through this one, try to keenly observe. Observe keenly here, because very important. Easy also actually, if you know, it will be very easy for you. Right? So, and here see, actually you are learning only two reactions only. One is combination, opposite is decomposition. Second one is you are learning about the disproportionation. So opposite is the proportionation. So the meaning is you are writing only two reactions only. If you know the two reactions, just you are writing the opposite That's all that is about the, okay. So this is all about the combination decomposition. Okay, this done. Chalo. Now next one is redox reactions are divided into two main types. Okay, one is called intermolecular redox reaction and the second one are called intramolecular redox reaction. Intermolecular redox reaction and intramolecular reduction reaction. So this is very simple here. Actual redox reaction, see, this all we can give like that only. Okay, so for here you see combination and decomposition. If you see combination and decomposition, two different elements are undergoing the oxidation and reduction. Two different elements are undergoing the oxidation and reduction. So that is nothing but a intermolecular redox reaction. See the definition of your in the text material page number 84. The redox reactions in which one molecule of the reactant is oxidized, whereas molecule of other reactant reduced. So one molecule is undergoing the oxidation, other one is undergoing the reduction. So here also you can see one is undergoing the oxidation, second one is undergoing the reduction. So this type of reactions are called intermolecular redox reactions. The same example you can give. In your material given different example, but you can write this example only, no issue. Now next one you see intramolecular redox reactions. Intramolecular redox reaction is what? The redox reaction in which one atom of the molecule is oxidized and other atom of the same molecule is reduced. Okay, so that is okay. So here we can give. Here we can give like this an example. Okay, what we can give? One example we can give here. MnO7. Okay, it is decomposing into MnO2, manganese dioxide, and oxygen. Okay, so here if you see oxygen is -2, you know that oxidation number -2 sevens are -14. Here this should be Mn2O7. Yeah, so -14. -14 means what? Here it should be 2 are there, so this should be +7 because +7 2s are +14, -2 7s are -14, so they should be equal. So never oxidation number is +7 and -2. Here you see now. Here -2 is oxygen, -2 2s are -4, so this is +4 and here it is 0. Okay, so hope you are understanding how to write the oxidation number. This is very important. Okay, you need to practice a lot. Now the redox reaction in which one atom of the molecule is oxidized. So this is one molecule. In this one molecule of the atom is oxidized. Which one is oxidized? -2 to 0. Okay, increase in the oxidation number. So oxidized. Okay. And the other atom of the same molecule, +7 to +4 reduced. Okay, then it is called intramolecular redox reactions. If two different molecules, two different molecules, they are undergoing the oxidation or reduction, then we can say that that is intermolecular redox reactions. But within the molecule, this is total one molecule only. Within the one molecule, if they are undergoing the oxidation and reduction, then that's called intramolecular oxidation or redox reactions. Okay, so students, that's all. So with this, we completed this chapter. Okay, now open your material. So now let's see the questions here. A reaction in which oxidation and reduction takes place simultaneously is called. Very simple. We are discussing about that only. That is redox reaction. Option is 3. Option is what? 3. Now, all displacement reactions are only oxidation, only reduction, redox, combination. So, this is redox reactions. Okay. So, once again the answer is 3 only. Right. Now, then come to the next reaction. Chlorine plus sodium hydroxide gives rise to sodium chloride, sodium hypochlorite plus water. This reaction is an example of. Then you need to check here which type of reaction is this. Okay, so I'll write the reaction and I'll give 1 minute time to solve. You try to solve it and you try to say which type of reaction is that. So chlorine and it when reacting with the sodium hydroxide, and it forms a sodium chloride NaCl, and also forming sodium hypochlorite or NaOCl plus water. Okay, now you check here what is its oxidation number. You check and you say which type of reaction is this. So here you can see, once you have to refer to understand this one. Okay, this is either the disproportionation reaction or it is a proportionation reaction. Okay, so here disproportionation reaction, what I said here, one element only undergoing both the reduction and oxidation, that is one. And here what about two different elements undergoing the oxidation or reduction. So now you compare within these two. Oh, I will left one page. So now you compare these two. Okay. So here you say chlorine oxidation number is 0 because it is individual. Here sodium is +1, oxygen is -2, hydrogen is +1. Here sodium is +1, chlorine is -1. Here sodium is +1, okay, and oxygen is -2. Correct? Oxygen is -2. If oxygen is -2, then chlorine is +1. Okay, and here hydrogen is +1, oxygen is -2. Right. So here you see sodium is +1, sodium is +1. Sorry. Here sodium is +1, oxygen is -2, so it should be +1. Okay. So sodium is +1, sodium is +1, sodium is +1, sodium is +1, no change, leave it the sodium. Now oxygen is -2, oxygen is -2, oxygen is -2, leave it. Hydrogen +1, hydrogen +1, this. Now left what? Chlorine. So chlorine 0 to -1 here, 0 to +1 here. So reactant side is only one element which is undergoing both oxidation and reduction. So here reactant side is only one element. This is undergoing oxidation, this is undergoing reduction. So one element only, both undergoing oxidation and reduction. So what type of reaction is this? Disproportionation reaction. Okay. So students, answer is 3. Take it. The reverse of disproportionation reaction is what? Just now I told you that. The reverse of this one is what? Proportionation. Right? So the answer is proportionation reaction. So the answer is, fourth option is what? 1. Correct? Fourth option is 1. So answer is what? Fourth one, proportionation reaction. Okay. Then go to the fifth one. The redox reaction in which one molecule of reactant is oxidized, whereas molecule of other reactant is reduced. Just now I told you different molecules. Okay, then the answer is what? Intermolecular redox reaction. So which option is there? Oxidation reduction, intermolecular redox reaction. So that is fifth one. And now see the redox reaction in which one atom of molecule is oxidized and the other atom of the same molecule is reduced, and this is exactly opposite, intramolecular. Is there a oxidation reduction, intramolecular? So fourth option is the right answer. Next, which of the following is not a redox reaction? Okay, so barium oxide +2 -2 0 +2 +4 -4. So let us check. Now we have to, this type of reactions you need to work hard here now. Okay. So now see the 7th question. Barium oxide plus O2 gives rise to barium peroxide, Ba2O2. No, BaO2. Right? Right. Now here you see now, here oxygen is -2, barium is a +2. Here oxygen is 0. And here the barium is +2, okay, oxygen is -1, correct? So now here +2, 2, sorry here, so here oxygen is what? -1 we should take here, because this is +2. Okay. So now see here, oxygen is -2 to -1. Okay. So this is reduced, right? Your oxygen is 0 to oxygen is -2. Oxygen is -2. Barium is -2 means what? +2 means what? Oxygen is -1. So students, here if you see barium is +2, it's right. Barium can't be +4. Barium. Yeah, it's +2 only. No cheat about that. So barium is +2, +2 no change. Oxygen is -2 to -1 decreased. 0 to -1 also. Sorry, -2 to -1 is increased, right? Okay, once again we'll check. So here you see, here oxygen is -2 to -1. -2 to -1 means what? It is increased. So that is oxidation. Here 0 to -1 it is decreased. So this is reduction. So the first one is redox reaction. Now second one we see BaO2 barium oxide plus H2SO4. H2SO4 gives rise to barium sulfate BaSO4 plus what is given? Hydrogen peroxide H2O2. Chalo, now you see here. Here this is +2, this is -1, +1, 6, -2, +2, +6, -2, yeah, +1, -1. So these are the oxidation numbers. See, oxidation numbers how to write already we discussed, so we have to practice. So barium is +2, barium is +2. Oxygen here is -1, here oxygen is -1. Yeah, hydrogen is +1, here hydrogen is +1. Here sulfur is +6, here sulfur is +6. Here oxygen is -2, oxygen is -2. There is no change here. All are exhibiting the same oxidation number. So this is not a redox reaction. So your answer is second option is the right answer. Okay. Next, which of the following is metal displacement reaction? Zinc with copper sulfate gives zinc sulfate copper. Yes, because zinc is more reactive than the copper. So zinc displaces the copper to form the zinc sulfate. This is the right one. Sodium with water? No. Calcium with water? No. Mercuric oxide? No. So displacement reaction is only one only. So that is first one is the right option. Ninth one. Which of the following is an intermolecular redox reaction? Intermolecular. Intermolecular means what I said? Two different atoms of different elements. Okay. So see intermolecular, the redox reaction which one molecule of reactant is oxidized, whereas the molecule of other reactant is reduced. Right? So here first one no, second one no, because only one reactant saw there. These both are not possible. Third one, two reactants are there, correct only, but here you need to check. Chromium, no, this is wrong. And this arsenic, AS, and nitrogen, yeah. So see students, here in the first one, sorry, the fourth one, arsenic. Can you see the arsenic? Here it's exhibiting the +3 oxidation state, and the next one it's exhibiting the +2 oxidation state. Okay, and in okay, I'll write. You don't understand, I think, if I say like this. The fourth reaction, if you see, fourth reaction is arsenic As2OS3 combining with the nitric acid HNO3 gives rise to H3ASO3 O4 plus H2SO4 plus NO. So now observe carefully here. Here sulfur is -2, -2 3 is a -6, so this should be +6. +6 means what? It should be +3, because +3 2 is a +6. -2 3 is a -6. It becomes 0. And here oxygen is -2, -2 3 is a -6. Here +1, so this should be +5. And here you see hydrogen here +1. We know that oxygen is -2, -2 4 is a -8, and here +3, so this becomes a +5. So this becomes a +5. And here hydrogen is a +1, sulfur is a 6, so oxygen is a -2. And here oxygen is -2, then nitrogen becomes +2. These are the oxidation numbers. Okay. So if you say, yeah, main element here arsenic, arsenic is +3 here, and here it is +5, +3 to +5. So this is what increased, means oxidation. Here nitrogen, if you see plus 5 to here plus 2, means what? Decreased. So reduction. So this is which of the following is intermolecular? So a reduction reaction is taking place, redox reaction is taking place, and one molecule of one atom is undergoing the oxidation, other molecule of other atom is undergoing the reduction. So this is called intermolecular redox reaction. So the answer is 9th one. Okay, 9th is the right answer. Sorry, 9th one, 4th is the right answer. Correct. Now last and final one, let's see the 10th one. Which of the following is a redox reaction? 6 students. Write the oxidation numbers. You do this one. So write the oxidation numbers and where the oxidation numbers should increase and decrease, then that is a redox reaction. So once you check, okay, you'll come to know. You'll write it. Okay. So that's about this one. And the remaining you practice. What is this? 85. Where's the pin number 86? 85. Chalo. So try this one. Okay. With this we stop today's class. So with this synopsis 5 of stoichiometry, which is the last topic of this stoichiometry and mole concept. This is the last topic. So with this chapter is done. Okay. Now left with only one chapter, students. That is, I think, behavior of gases. Something chapter is there that we discuss. Okay. So until, take care. Bye.